Hi everyone and welcome back to my channel A in Economist. So in the previous few lectures we have understood the concept of relations and functions, and we have solved multiple numerical questions on that, and I had given you some homework questions which I'm sure that you have tried on your own. In this video we are going to solve these questions and then we will discuss some other concepts. If you haven't watched my videos on relations and functions, I will give the links in the description box. I want you to first look at the concept videos and then solve the questions with me, right? So let's start. Find the domain of each of the following functions. Let's do the first question. Y is 1 upon square root of 3 plus x, 7 plus x. Now we know that within the roots this particular product has to be greater than equals to 0. Now here you have an additional constraint that you have a square root here. So this thing has to be greater than equals to 0, that's for sure. But since this term is in the denominator, it cannot be 0, right? I hope this is clear. This term cannot be 0. So we have two constraints here. This product has to be greater than 0 and it cannot be equal to 0. So let's go ahead and solve this question. This is question 1. 1 is 3 plus x and 7 plus x, right? So what can we do here? And we have a square root of that. What can we do here? We consider the first criteria. 3 plus x is greater than 0 and 7 plus x is greater than 0. This could be the first case. And what is the second case? 3 plus x is less than 0 and 7 plus x is less than 0, right? Now let's consider this cases one by one. If you see the first case, 3 plus x is greater than 0, right? So x is greater than minus 3 and x is greater than minus 7. Again, if you draw the real number line, this will be a little more clear to you. Here you have minus 3, here you have minus 7. So x is greater than minus 3 and x is greater than minus 7, right? So what is the common part? You always look for the intersection part, common region between the two. So if you combine this thing, you have and in between. If you combine everything, what you will have? You will have x is greater than minus 3, right? X is greater than minus 3. So this region will come in the intersection portion. So this entire thing can be combined into this. If you say x is greater than minus 3, it will automatically imply x values are greater than minus 7. It is clear from the diagram as well. Now let's look at the second criteria. X is less than minus 3 and x is less than minus 7. Again, if you draw the real number line, if you have minus 3 here, minus 7 here, suppose x is less than minus 3 is this entire region, x is less than minus 7 is this entire region. So what is the common part? This part is common, right? So again combine this and you will have x is less than minus 7. So what will be the domain? What will be the domain? Domain of this function can be written as this: all the x values which belongs to real number such that x is greater than 3 and x is less than minus 7. So you are taking this value and this value and you are putting and in between. So domain will be all the real numbers such that these two criteria are satisfied. So this will ensure that this thing in the domain is greater than 0 and it is not equals to 0, right? So this will be our valid domain of the function. And this is our first question which is done. Now let's do the second question. it's a similar question. Let's do this. 1 upon x minus 3 and you have x plus 7. Let me see once. Yeah, you have this and a square root of that. So again do the same thing. Consider the two cases. X minus 3 is greater than 0 and x plus 7 is greater than 0. And the second case is x minus 3 is less than 0 and x plus 7 is less than 0. Then evaluate these two cases. Right? Now you have to combine these two things. Draw the real number line. Right? Here you have say 3 and here you have say minus 7. X is greater than 3 and x is greater than minus 7. So the common region is this. So if you combine this entire thing, it will come out to be x is greater than 3, right? If you say x is greater than 3, it will automatically imply x is greater than minus 7 as well. Now do this part. You have x is less than 3, so this portion, and x is less than minus 7, this portion. So this part is the common region. So what you can combine and write, you can say it is minus 7. So what will be the domain of the function? It will be all the x values which belongs to real number line such that x is greater than 3 and x is less than minus 7. So this is the valid domain of the function. I think you have understood the process. The process is the same. It's just considering the cases and evaluating them one by one. Now consider question 3. Y is 1 upon 3x minus 1. Y is 1 upon 3x minus 1, right? You have this. So this denominator can't be 0. So 3x minus 1 is not equals to 0. So x is not equals to 1 by 3. So you can write the domain to be all the x values belonging to R such that x cannot take the value 1/3. Or what you can write, the domain is all the real values except the value 1/3, which also means this except 1/3. Right? So this is question C, done. Now the final question says y is root over of 7 plus x. Y is root over of 7 plus x, right? So this thing should be greater or equals to 0. It is in the numerator, so there is no need for making it strictly greater than 0. It can take the value 0. It has to be non-negative. So x is greater equals minus 7, right? So what will be the domain? The domain can be written as x belongs to, it can be written as this, or you can write the domain to be x values which belongs to R such that x is greater than equals to minus 7. So this homework questions are done. Now next we have the range of a function. Range is all the possible y values. Y is nothing but the f(x) values, right? If you are given some particular x values, you need to find the valid f(x) values here. So x is given to be minus 3 to plus 3. So if you square both sides, what you will get? X square is 9, right? X square less than equals to 9 means x lies between minus 3 to plus 3. But this x square is nothing but f(x). So what is the valid range of f(x)? Range of f will be all the f(x) which belongs to R such that 0 less than f(x) less than equals to 9. We have another question, y is 2x plus 1, find the range when the domain is given as this. So here what you need to do, you have to put in the x values one by one here and see what is the y value. So put -3 here, you will have -6 plus 1, -5. Put -2 here, -4 plus 1, -3. -1 here, -2 plus 1, -1. Put 0 here, you will have 1. Put 1 here, you will have 2 plus 1, which is 2. Put 2 here, you will have 4 plus 1, which is 5. And put 3 here, you will have 6 plus 1, 7. So if you want to write the set of ordered pairs, you will have -3 -5, -2 -3, -1 -1, 0 1, 1 2, 2 5, and 3 7, right? Okay, so what will be the range? Range will be -5, -3, then you have -1, then you have 1, then you have 2, 5 and 7. So just taking the second values here, right? So this is all you have. Again, I have some homework questions for you. Try this by yourself first, and in the next video I will solve this question and move to some other concept. Thank you for your time, and if you haven't subscribed to our channel, do subscribe it and share it among your friends so that you keep on getting this useful content. Thank you for your time.